Okay, you need to learn how to determine the allowable values, because if you see here the table is given, and most of the confusion begin when they see the value. Okay, this material, this is thickness range. I don't think that's a big issue, but the issue now when there's value A, B, A value, B value, L and LT. So you have to understand how this value, what are the importance of this value. Okay, this value L is A value here. 90% of the time when they did the test on the material, that is what they get. So FTU, 99% of the test they got 435 megapascal, and 90% of the time the test they got 440 megapascal. So mean that chances for them, this is high chances to get 435, but less chances is 440. I mean 90% they get 440, but you go refine, the chances of the result is 435. Okay, why this two is important? Because for the primary structure, this is the one that you use because it's more conservative. Mean it look like the material less strength. But for the non-primary structure, we may use this because this is less conservative. And you can see the difference why we need to use this and why we use this, because these tend to be heavy, less strength. So you have to have thicker material. And here look like higher strength, so material can be thinner. So that is why we have to choose when to use A, when to use B. A is used for the critical structure where we need the strength and we need the confidence of the strength for the value. And also another one, we have to look L and LT. L and LT is how the material is manufactured. So if you manufacture a material, if you make a roll for sheet metal, okay, the sheet metal it come in roll. Yeah. If you open up the roll, it become plate. So this is L. This direction is LT. L because when you manufacture in roll, basically draw in the material in this direction. So most of the grain will be this direction. That's why L. So why L? L, you can see if you cut this piece for your doubler. So L, you can see L here is 435, and you can see LT is L is 435 megapascal, and LT is, if we cut the material this direction, we load it into this direction, so we use 405. So you see the difference is huge difference. For this, if you want to use this value, you have to make sure you ask the mechanic to cut the doubler. If you want to apply tension load or doubler, you have to cut LT in the LT direction. You have to be very specific, or else we do not know whether maybe they cut into the LT. This L, this LT. So LT, the grain is like this. So just like want to break it apart. But here the grain is like this. So if you want to be specific in using the value, you must, in the instruction, you must tell how to cut the repair plate, either an L or avoid LT if you want to use 435. For us, repair is not, because the problem between here and here is weight. If we use this value, okay, lesser weight because very strong, so less thickness. Here you need to have thicker, heavier with the same load. So for this case, so for you, for me, in the past when I was doing the work, because we are not going to have very massive big repair, we just try to be conservative. What I did is I just choose the lowest. So FTU, I just choose the lowest. But it's not a good practice. However, it's enough for me at the practice because we are running out of time. We do not have much time to check how the mechanic cut the plate. Then I just use 405. Similarly, if you have extruded angle, okay, extruded angle. So this is L direction. So this is the LT direction. L direction, I can say is parallel to the grain. and LT is transverse to the grain. So when they draw in this to get L, there's a billet here. They draw through the die, okay, the die push through and then come out with this angle shape. So that is how we need to determine engineering allowable values, and you have to know what is A, B, L and LT. So that is how we identify those values.